Welcome to clickmyproject.com. Let we discuss about the process detection of exudates in color fundus images. Let me see the abstract of the process. Eye is a vital organ and it is the main organ that is commonly affected due to diabetes. Different types of diseases were present in eye due to diabetes. The detection of the exudate and hemorrhages in retinal images will be helpful in the early identification of diabetic retinopathy, and it can be more helpful in providing treatment for patients. The images were first identified to be normal or exudate affected or hemorrhage affected. The identified defects were then segmented from the images. The performance of the process is measured by measuring the classification parameters such as accuracy, sensitivity, and specificity. The retinal images were initially resized and they are filtered using median filter. The filtered images were then classified as normal, hemorrhage affected, or exudate affected based on the features extracted. The GLCM features were used for the classification of retinal images. GLCM stands for Gray Level Coherence Matrix. Different segmentation methodologies were employed for different types of defects identified. The exudates were segmented using morphological operations. The hemorrhages were segmented using thresholding process. The performance of the process is measured by calculating the performance matrices of the classifiers such as accuracy, sensitivity, and specificity. In other than that, confusion matrix and ROC curves were identified in order to measure the overall performances of the process. Let me see the flow of the process. So in this process the input images were obtained. The obtained images were commonly resized and then filtering processes were employed based on median filter. After that the features were extracted from the images using GLCM algorithm and Gabor wavelet algorithm. The extracted features depicts the texture-based informations from the images. The extracted feature values were then passed into as input to the classification methodologies. So for classification we are employing support vector machine classification. So in the support vector machine classification the feature vectors were classified as hemorrhages or exudates or normal. So based on the different classifications the labels were provided for the input images that are provided in the training set, and based on the comparisons of the labels and the predicted classes the final result of the classifier is obtained. So the input image is classified into hemorrhage or exudate or normal one. Finally, the overall performances of the processes were measured in terms of the accuracy, sensitivity, and specificity of the processes, and also in each step the segmentation processes were employed. While segmentation, then for normal images the optical disc regions alone were segmented, and for the abnormal regions the abnormalities were segmented from the images. Also the blood vessels were also extracted from the images. Let me see the running procedure of the process. If you want to run the code, select the file main.m which is located in the source code folder. Right click it and click on run file. You will get the process getting started. Select any one of the images which is present here and click on open. Now the process will be started. The input image is displayed, color style is separated, displayed, pre-processing is done, features were extracted. After that classification is extracted, then segmentation processes, finally performances were all employed. So this is the input image that we got. So the color channels from the input images were separated as red, green, blue, and the three color channels were separated. After that, they pre-processed the images displayed here. So this is displayed after pre-processing, which is based on the median filter operation. The input images were commonly resized to size 256. Now the feature extraction process. So here the first features were extracted based on the Gabor wavelet. Here the extracted orientation values in each iterations were displayed here, and the values extracted for each orientations were displayed here. After that, this is the GLCM features extracted from the images. Basically 12 GLCM features were extracted from the images. So these features depicts the texture based informations from the images that we are extracting. So this will be the input for the classification process. So the SVM classification is done, and the classification classifies the input images as normal image. So normal image, no segmentation needed, localization of OD is enough. So this message is displayed. So the next process, we move on to the segmentation process. So we segment the input images. The OD regions were segmented, and also the blood vessels were extracted from the images. So this is the identified OD pixels. Normally brighter region will be the OD pixel in the input image. Based on that, the brighter regions were extracted, and after that the regions is segmented and it is extracted, and finally the images were obtained. After that, the blood vessel extraction is done. So the blood vessels may be are obtained based on the morphological operations, which is employed by identifying the closing the open operations and the subtraction of the regions is abstracted from that. So the blood vessel regions were extracted and they were segmented in the images. So this is the overall performances measures extracted in our process. So first, the OD localization performance. This is performed by comparing the segmented optical disc regions based on the exact optical region segmentations, and based on the accuracy, rate, precision, and recall were extracted for the regions. So then after that, the classifier performances measures were extracted. Here the classification performance measures means the regions were extracted based on the classification of the SVM classification is based on that the parameters were estimated. Then after that, this is the receiver operating curve obtained. So this receiver operating curve is the plot of sensitivity and the specificity. So based on the obtained values in the sensitivity and the specificity, the graph is drawn. So here the one is the maximum ranges that we are obtaining. So here we obtain the maximum ranges up to 0.8 something. After that, this is the confusion matrix. The confusion matrix identifies whether identifies the overall performances depicting all the values, that is accuracy, sensitivity, specificity, also the true positive rates, true negative rates, like that. So all the overall performances were calculated in the confusion matrix. Thus we are providing segmentation and classification methodologies for the detection and detection of X-rays in the retinal images presented in the this is caused due to the diabetic retinopathy. Thank you.